This is Mark here with an IQEngine demo. Today I'll be showing off the current features of IQEngine and then talking about some of the future plans. And this was made on February 4th, 2023. So on the main page, we have links to public repositories of RF recordings. There's currently just one, but the idea would be for there to be a bunch. Like each RFML data set could be a whole tile or someone's collection of recordings. Each one represents a different storage account. And then you can also open local SIGMF recordings, either a local directory, like so, where you can see all the SIGMF files in the directory. Or you can open up a specific pair where you have to choose the data and the meta file, and it brings you straight to the spectrogram page. And then the last option is to put in your own Azure storage account containing your SIGMF files. And if anyone is not aware, SIGMF is simply a metadata format for raw IQ recordings, where the data is stored as binary IQ, which is the most common way to store RF data. And then SIGMF specifies a metadata standard, which uses JSON. Anyway, so if we look at the first tile here, this is a collection of example recordings hosted by GNU Radio. It's kind of just a random mix of recordings that'll grow over time. Now it shows you the recordings and folders in this storage account. And this information here all came from the meta file of each recording. Now, whenever a recording is uploaded to the storage account, there's an Azure function that automatically generates the spectrogram thumbnail, which is then used by the website. That's why the local files don't have the thumbnail. So here's a bunch of Daniel Estevez's recordings. Not sure what's up with this one. We have some synthetic ones I created in GNU Radio. This is fun for testing filters and such, like having a very strong tone next to a weak tone. In fact, you can't really make out the weak tone here. BPSK, QPSK. So the idea is on this screen you see the list of recordings. You can get a quick glimpse into the data set or the collection. You can see like which ones are annotated and then how many annotations there are. You can click and actually see like how much other data is going along with each annotation. Author, email, and then the data type and the length of each file in units of IQ samples. So you can download the data and meta files directly here, each one. And then if you click here or click the thumbnail, you're brought to the spectrogram page. And this is kind of the main tool for doing the signal analysis. So we have the main spectrogram here, and then on the right is this scroll bar that uses a mini map, kind of like VS Code, where this represents the whole file, and then this gray part represents the part we're looking at. And you can drag this. And what's awesome about IQEngine is it only fetches the data you're looking at. So that's why when I jump to a new part, it has to download the IQ samples. And we can see the SIGMF annotations here. We can actually change them, and it automatically saves it, at least locally. We're using a read-only token for the storage account, so we can't actually save it back to the storage account, although that's a future feature to be able to do that. But right now, all you can do is change it and then download the new meta file. You can also view the meta file at the bottom here. So this is the SIGMF meta file, and this will get updated as you change annotations or rename stuff. And you can even change it here. Oops. Oh, I guess you can't. That'll come at some point. Okay, so And then you can download the new meta file. What you're seeing here, you can download with this button. It currently kind of glitches out, and you have to go back to it, which is a bug. Okay, other features. So you can select an area in time and then view that portion of samples in time, frequency, or IQ. And you can change this. A future feature will be having these selection bars actually show up on the mini map, so you can sort of, cover way more than a screen size. And by the way, the current canvas here is hard coded to 600 by 600 pixels, but the idea will be to automatically scale it to the width of your screen as well as the height, where each row is 1 FFT, and then on the width, it's just whatever size your FFT is gets scaled to the pixels you're displaying. So right now I've got 1024 size FFTs being scaled to 600 pixels. I could change this to 256, and you can see it sort of zooms in time. The frequency plot is always one big FFT currently. You can change the color scale, so depending on the dynamic range you want, you could adjust this from 0 to 255. There's this auto scaling which tries to use the variance. Oh boy, that just glitched out. The idea with auto scaling, it doesn't really work right now, but it looks at the variance of the signal to try to figure out what's a good min and max. And you click it and then scroll is how it works. Okay, there we go. So it kind of worked there. Yeah, that needs some work. So FIR filter taps, you can specify real or complex taps here, comma separated. And then I have some example taps. The idea would be to add a bunch more here, example filters. So as you can see, it filtered out everything but the center 50%. The data type currently doesn't do anything because it automatically figures out the data type from the SIGMF file. But at some point, I want the ability to open normal binary IQ files that don't have a meta file. And for those, you'll have to manually choose the data type and the sample rate. So for the FFT, you can change the window, which is more clear when you're looking at a tone. So let me go to the synthetic and then go to tone. So if I change the window from Hamming to rectangle, you can see a little bit of difference there. Hanning, Bartlett, not a big difference. I'll talk about the Python snippet and detector in a second. You can look at the information in the meta file here, and you can actually change it. So in fact, if you look at the top scales, it's kind of cut off, but this shows you the, this is a bad example because I set the sample rate really low. Let me go back to the cellular one. So in this example, the sample rate is 40 megahertz. And you can see the top scales go from -20 to +20 megahertz. So if I change this to 10 megahertz and hit save, and then I have to refresh the screen, but you can see it's now saved. And then if we look at the metadata, the sample rate's now 10 megahertz. So you can edit the global metadata here. You can put in a description, author, and actually fields. So really any field in the global is going to show up here. This just it parses the meta file, and whatever field you have, it'll show up here, and then you can edit it. And in the future, we want a way to add a new field. Annotations currently empty, mainly because they're being displayed down here. So I'll probably remove that part. Okay, so that's kind of the current features other than the plugins. So there's this whole other concept behind IQEngine involving plugins where people can kind of customize it to their own needs. So I have this little page that tries to explain the idea. And I separated plugins into 3 classes. The first one is this idea of performing signal detection with optional classification, where you would send it a batch of IQ samples. For example, it could be chosen with that selector, the horizontal bars that we saw earlier. And then it would return a list of SIGINT annotations corresponding to the detections. So if there were no detections, it would be an empty list. And then you would be able to immediately visualize the results on the spectrogram. Now this is actually currently implemented in a minimal form. I'm going to use this synthetic signal here for an example. So if you go to the detector page, there's currently only one real detector implemented. You have to first select the region you want to run through the detector, and then you run the detector. And there's currently no like progress bar, and this thing takes like 10 seconds to run, so that needs to happen at some point. But it's actually using a back-end process to run the detector. Everything else is on the front end. But it's using a REST API, taking the front end is grabbing the samples and calling that API, and then receiving the SIGINT annotations. And I believe it's, it adds the annotations to the metadata, so it's immediately available. And yeah, that's it. So that was the results of the detection. It looks like there was one kind of anomaly over here. But these ones worked. And what's missing right now, obviously the progress bar so that you can like watch it work. And then a list of parameters for each detector should be under here. And I think the way that's going to work, for the sake of like not having to hard code everything, is you'll choose a detector and then hit a button that says like get parameters, and then it'll populate the form where you can fill out you can tweak any parameters associated with that detector, and then hit submit, and that would actually trigger it. So still some work to do, but the base plumbing is there. And as far as implementing your own detector, so I have it uses a REST interface, and I created sort of like a API where every detector always uses the same format, where you give it the samples, sample rate, center frequency, and then an arbitrary list of key value pairs that's one layer deep. And that would be, those key value pairs would be what shows up here, because the sample rate and the center frequency are automatically found by parsing the meta file. So currently the detector is implemented in Python. So if you wanted to make your own detector, if you did it in Python, it would be really easy to add your own, versus C++. I don't currently have the plumbing set up for that yet, but I do plan to do it in the future. Okay, so that's the detector plugin. By the way, the classification would simply be setting the label to whatever class of signal it detects. So that's easy to implement from a plumbing perspective, that is. Okay, so the second type of plugin is a DSP module, which is essentially a block of DSP code that manipulates the IQ samples before the FFT is taken. Currently, it only supports a Python snippet, but in the future, we definitely want C and C++ blocks, essentially like a new radio. And the way it works is the code runs on the back end, and it's partially implemented right now. So right now, if you run IQEngine normally, it grabs the samples straight from blob storage. It fetches the IQ samples directly. But the idea with this Python snippet and other DSP blocks that run before the FFT, which is done client-side, by the way, the FFT is client-side, you would type in your Python snippet. Let's say I want to look at, let me switch to a BPSK signal. And then let's say I want to look at x, the signal squared. So the way this works is x is the signal, and you can manipulate x. So I can say x equals x squared. You hit run, and they have to reload. No, actually, sorry, I don't need the x equals. All right, there it goes. So if you know the trick with DSP, if you square like a BPSK or a QPSK signal, you can find the carrier frequency. So that's why there's a tone at 0. Might be more clear on the frequency plot. You get the tone at 0. So if there's a frequency offset, we would be able to detect it easily with this tone. Anyway, currently it only supports a single line, but the idea is you'd be able to say like x equals that, and then maybe you could do like a convolution, convolve with a list, or you could create your own like kind of block that lives somewhere else, and you would sort of choose it like you choose a detector. But what I was getting at was this runs on the back end, and the way it works when there is a Python snippet is the back end pulls the samples from blob storage, runs them through the DSP, and then serves you the result. And then your client does the FFT like normal. So that way you're not like grabbing them from blob storage and then sending them to the back end and then getting the result back. That would be much less efficient. So you can do a pretty complex DSP if you have the back end resources. Right now this site's being hosted by GNU Radio's Azure credit. And even though right now we have like a ton of credit, we won't always. So at some point, the backend features might not be publicly available, or they may be limited. We'll see. So that's the kind of the DSP block. The last type of plugin is a signal generator, where you would give it a set of parameters and choose a type of signal, and then it would create a new signal. So this plugin would actually be accessible from this screen here, or even this screen potentially, where you don't need a storage account or a local file. You can start from nothing and say, hey, I want to generate a new signal. And you could generate tones, normal like common digital modulation schemes, noise, all that kind of thing. I also want to be able to add noise to an existing recording, or a tone even. That way you could sort of, augment a recording and add to it. I think once the SIGGEN, front end and back end is implemented, it'll be easy to sprinkle it in everywhere else. So that's the third type of plugin. And if you have ideas for any others, definitely bring them up. So, if you want to get involved, the first place to go, I'd say, would be the GitHub for IQEngine. This is kind of like the main website's repo. There's also a repo for the backend stuff here and detectors. And then I've been playing around with WebAssembly. But anyway, the main repo is this one. So currently I have a big list of features and ideas here. So if you have ideas, you can extend this thread, or you can make your own new issue with ideas or bugs. And then even better, if you actually implement a feature or fix a bug, you could add a PR. There's also a Discord linked here. And then you can email me with this address. And then lastly, I have a newsletter. I'll send roughly once a month updates to folks on this newsletter, and you can sign up here. In fact, this video is going to go out as the first post on the newsletter. So that's all for now. I think IQEngine has a lot of potential, a lot of different kind of use cases. I think for RFML, it'll be really nice. But even for folks not interested in machine learning, if you're someone who uses in Spectrum, the idea would be this will eventually do everything in Spectrum can do. If you do wireless CTFs or really any kind of general signal analysis, signal intelligence kind of stuff, I think this will be a really useful tool. And then most importantly, for me at least, on the education side, I'll be adding a bunch of more education-oriented features. Like, for example, right now it does an FFT to produce the spectrogram, but there's other ways to produce what is essentially, a time frequency spectrogram, such as wavelets, and you could use a channelizer instead of an FFT. So I'm planning on implementing those and then having kind of like a tutorial that explains how they work, why you would use them, and then how to actually, manipulate the settings within IQEngine. And even right now, there's educational features. Like if someone's totally new to DSP, you can learn about FIR filters and how taps work. So I linked to my textbook, PySDR, the filter portion of it, where someone could learn about how FIR taps work, and then they could play around with the taps. FFT size, I linked to that. What does the size really mean? What is windowing? So I think this has a really nice use within kind of DSP and wireless communications education. And if anyone's interested in kind of going even further with IQEngine used in education, definitely reach out. There's a lot of groups that I think are interested, and it'd be great to sort of get together and talk about it. But yeah, I think that's all for now. If you have any RF recordings that you want to share publicly, this is a great way to do it. If you have a ton of them, I could make a new tile for you, like this example here. And you don't need your own storage account. While GNU Radio has enough credit, I can use that credit to host your files. And I can always link to your website in the description. If you only have a few files, we could add it to GNU Radio's main collection. I could add a new folder here. So we have like Daniel Estevez's space recordings. We've got some drone recordings that I found in the public domain. And then there's some DeepSig stuff here. Yeah, definitely reach out. Yep, that's all. Thanks for watching if you got this far.